Okay, so this week we're going to be covering Chapter 8. We're just going to not try to catch up. We're just going to do a chapter a week pretty much from here on out. I think that's probably enough. So starting with Chapter 8, we're getting back into the creation of classes. And I'll talk about that as we go through that chapter. Okay, a couple other notes. I sent an email out about homework to everybody, and Moodle apparently doesn't show that it just went to everybody. Some people thought it was just directed at them. It was not, and I need to say hello everyone or hi all or something, and I didn't. Okay, so that was just a general email. A lot of people were asking about homework, when they could turn it in, and all that stuff. So just to be clear, we're going by the syllabus. If you're going to be late for homework, and some of you have had reasons to be late, perfectly okay. Just make sure that you let me know in advance that it's going to be late. I'll give you extra time. Things will be good. Okay. Again, the fear is that since this class is a chapter a week, if you don't get this week's homework done on time, it gives you less time to do next week's homework. And that's the concern I was trying to express in the email. Okay. And then the other thing that comes up sometimes is that if you upload the wrong file for your homework, well, let me know. We can upload a new one. That's not a problem. But what I don't want to get into is correcting previous homework. Okay. Again, the main reason being that we have to be moving forward, that we've got next week's work to worry about. I don't want you perfecting last week and trying to figure that stuff out when there's this week's material to deal with. The next chapter will probably deal with issues from the last chapter, so it'll give you another opportunity to get those skills up. Okay, so that's kind of where I'm at. And that wasn't meant to be a mean email. It wasn't meant to be calling out anybody in particular. Just wanted to make sure that we were clear on things. I know that summer's busy. We've got a lot of stuff going on, a lot of family stuff, there's still work stuff related for all of us. The other class I was teaching is done now, so I'm down to one class, which is a good thing. Okay. Also, at the request of a couple of people, I'm going to move to a Tuesday, Thursday at 7 meeting time. Okay, and those will both be the opportunity for anyone that wants to come on, get help with homework questions or help with further explaining what's going on. Those will be about an hour each time. Okay, and hopefully that'll help out with things. Okay, if you have any questions about any of that, let me know. Okay. Okay, so let's talk about this chapter 8. So chapter 8 is titled Classes and Objects, a Deeper Look. Okay, that's really where we're getting. So let me go ahead and share the screen here with the iPad. It may storm here in a minute, so if you hear weird noises, could be what's going on. Okay, don't want my email, I don't want any of that stuff. Let's get this up. Okay, so I may switch back and forth somewhat between this and an Eclipse. We'll see how it goes. Okay, so again, this is chapter 8, which we're doing this week. The homework assignment's already out there on Moodle, so you can look at that. I think there are 4 problems in it. We'll talk about those a little bit at the end to give you a heads up as to what we're doing. Okay, so this again is on classes again and objects. Okay, so these are things that we can do the UML class diagrams for. Okay, we have the name, we have the instance variables. Those have to have the visibility. Are they public? Are they private? Is it an int? Is it a double? Those are all listed there. And then we have the methods down here. Okay, the methods have to have a return type, have to have the parameter type. Okay, so if you can do this, okay, then you are creating what I've been calling a class, okay, which means it's going to have the private stuff, it's going to have the accessors and mutators, and it's going to have this, okay? So remember that this is a reference to the instance of the class that called it, okay? So some more terminology. So again, class or class, okay, it's going to be an abstract, or let's say compound, a compound data type that we create ourselves. Okay, think of the employee class. Okay, it's we can take a concept like an employee, we can add some things that an instance of this class would know. okay, or information that should know about itself. That could be things like the name, such as maybe salary, whatever your program needs. It's also things that instance can do, okay? So it may be things like, get salary, okay, or set salary. Could be other things, okay? Could be get raise, whatever it is, okay? So again, we have the class is the cookie cutter, okay? Then we have an instance of the class. If I say something like employee E is equal to new employee, okay, then employee is the class, E is the instance, okay? The instance variables would be things like E dot name, okay? It's the name of the instance, okay? The instance has a name. Every instance, if I do another employee E2 is equal to employee, E2 would have a different instance of this variable, okay? So those are the instance variables. I can do things like get salary, okay? And again, that's the instance. When inside of the get salary, I refer to this, the this is going to be a reference, well, I want that draw there, to whatever's on the left side of that plus sign or that period, okay? If we get a static anything, static belongs to a class, not an employee. So not an E. So it belongs to employee, not E. So we could say employee dot whatever. And again, think of the example the book uses, math dot pi, okay? It's a static variable that belongs to that, okay? Then the other thing here that we need to say is that there is no main method and that it needs a test program or test application, okay? So that's kind of the overview of where we're at to make sure we're clear on that, okay? And I will say the testing's over, so everyone should have taken it, hopefully. I'll be taking a look at those this week, and I'll probably release a video with the solutions to that, would be my guess, okay? So the book's going to go through and just reiterate some of this stuff, okay? So you want this lecture is not instead of reading the book, it should be an adjunct once you've done that, okay? So on page 331, at least in my book, they've got the public class time 1, okay? So this time class we're going to have here, we have some private, and in UML class diagrams, we should put a minus for private. So we have a private int called hour, and my pen is wanting to be funny, hour, okay? I have a private int called minute. We have a private int called second, okay? And that's all we have there. And then when you look at the methods from that description, that's figure 8.1, okay, it looks like there is a to universal string, okay, that returns a string, got my box looking wonky, but takes no parameters, okay, and then there's also another function that returns a string, it's called toString, also takes no parameters, okay, those should have all been inside the oddly shaped box, but that's the idea, okay? So again, these are the instance variables, okay, and these are the methods, okay? So it talks about those methods there. Then there's another program, figure 8.2, is going to be testing the time 1, okay? So the test program is going to go through and make sure that you can create one. There's no constructor here. We're just using the default constructor for this. We'll talk about constructors more in a minute. But we have to test both the toUniversal string and the toString, okay? And in this case, at least yet, we don't have any accessors or mutators, okay? So that's all that example. The next section, A3, talks about controlling access to the members, okay? So on this one, it just talks about when we use public and private, okay? If we use private like we're doing here, then in our test program, you know, if I say something like time t is equal to new time, now t is an instance of time, I can't say t dot hour is equal to 12, okay? I'm going to get a violation if I do that because hour is private, okay? So we can't do that. So instead we have to create the accessors and the mutators, okay? We talked about this before, that you could just make it public. A public would have a plus sign over here. If you do that, then you could say this, it would be legal, okay? But when you do that, you give up the ability to control what data you have, okay? So the hour can be between 0 and 23, right? That's all it can be. So we're going to enforce that inside of the constructor and inside of the set hour, okay? The same thing for the minute and second. It can be 0 to 59. Okay, so it's the control we want, so we make them private, and we have our functions. A lot of times with our accessor and our mutators, we'll just have it pass through, okay? But you can do more than that if you want to, okay? There's another example here on the time case study with overloaded constructors, okay? So the way this works, every function has a default constructor, okay? But in this case, so we've got our public, it's a time2 class, okay? Takes no parameters. The this here is going to invoke the default constructor with 0, 0, 0, okay? To overload this, if we do another public time2, again, we couldn't normally do this, okay? But this time we're going to take an int hour, okay? So then we're going to call the this constructor, but this time we're going to call it with the int, with hour 0, 0, okay? Then we're going to have another one for 2 ints for the hour, the minute, then one with 3 ints, okay? And the one with 3 ints is the one that these call, and that's going to be the public, this is on page 339, public time2 that takes an int hour, int minute, and int second, okay? And then we're basically going to check to make sure that all of those are in the right format. And if not, we're going to throw an exception. Okay, so we're going to do the checks. Those are again on page 339. The checks there, but then we're going to say that this dot hour is equal to hour. Okay, so this hour is that hour. This hour with the this in front of it refers to the instance variable. Okay, so that's an example of overloading the constructor when it makes sense to do so. And it does make sense because sometimes you want to create a default time of 0, 0, 0. Sometimes you want to create a time with just the hour, sometimes with the hour and the minute, sometimes with the hour, the minute, and the second. Okay. So chapter 8.6 talks about the idea that every class has to have at least one constructor. So if you don't give one, it's going to create a no argument constructor. That no argument constructor is going to set the default for the variable type, a 0 for an int, a 0.0 for a float, a false for a Boolean, and all that to all the instance variables. Okay, that's all it's talking about there. Okay. Gets us to section 8.8 on composition. Okay, in composition, everything we've done so far with our classes has been an is-of relationship. Okay, So we did things like, we haven't done much inheritance yet, so let's forget about that. But so we'll get, that's the next chapter. I'm getting ahead of myself. We're going to do now a has a relationship. Okay. So for example, it could be if we create a date class, which they do on page 346. Okay, so you have a date class, and that's a class. Okay. You then have an employee class that for this employee class, one of the member data is going to be private date hire date. Okay. So it's the idea that you're going to define, in a public class, so you'll have a public class date that's defined on page 346, all that. Okay. And then we're going to take an instance of that to store in another class. That's composition. Okay. So we could say that the employee has a date. Okay. The next section, in section 8.9, talks about enum types or enumerations. Okay. And these are pretty interesting. These are ways that when you want to limit the number of options people have. Okay. So if you're looking at a program that's going to create what year in school are you? Okay. What high school or college year? Okay. Then you want it to be just freshman, sophomore, junior, senior. Okay. You don't want anybody freelancing anything else. Okay. And we can do this. We do a public enum class is a keyword. What do we call that? Like, I don't know, student, class, some name, whatever you want to call it. Okay. And then you can go through and define what's valid for that. Okay. But the enum, the enumerations, is more powerful than that. It's almost like if you've had C++, it's almost like a struct in C++. Okay. In that you can add some more things to it. So the example they give, figure 810, they're going to put, in fact, it's probably worth typing that in. So we're clearer as to what's going on. So I'm going to stop this share, pop up Eclipse. Hello, Eclipse. Eclipse is starting. Maybe. Okay, so it doesn't matter what we're doing in. We can do it here. It doesn't matter. Okay. So this is going to be, it's weird. They put it outside of everything, which is strange. So, I mean, I guess that makes sense because we're making it like a struct. So let's just go ahead and do this. So we're going to go ahead and do a new class. I'm going to not need the public static void main. Put it in the default package. So it doesn't like it. Oh, I haven't named it yet. Now it likes it. Okay, so we have our public, but instead of class, it's an enumeration. Okay, and then the enumeration inside of the brackets here, we're going to declare the content. So we can have a JHTP is the first one, and it's going to contain Java how to program, and it's going to contain 2018. Okay, so that's the first thing, the first member of our enumeration. Okay, then CHTP, which is going to be how to program, as the year of 2016. Okay, all the way down until we get done with that. Okay, don't know what's unhappy about that. I haven't used it yet, maybe. Oh, because I haven't got the constructor yet. Okay. So once you've done that, and there are more in the book, but that's the basic idea of we're setting these constants of that type. Okay. Then we have a private final string for title. That's the first part of those things we just entered. That's the book title. Okay. Then we have a private final string for copyright year. Okay. We now get to the constructor. So book string title string copyright year. Okay. Have this dot title is going to equal title. Okay, so it's book string title, comma, string copyright year. Yeah, I don't know why it's unhappy, because that's what copyright year. Yeah, we'll see what it's doing. And this dot copyright year is equal to copyright year. Okay, that closes that one. That was a typo. Okay, so that's going to be the constructor, and then we have to have the accessor for the fields. We can get to that. So we have a public string get title. Okay, which is going to return title. And then we have a public string get copyright year, which is going to return copyright year. Okay, and that's going to finish it. Okay, so that's going to be an example of an enumeration. Okay, what one looks like. Okay, and then to use that, okay, so when we use that in a program, okay, so we're going to do another program here. We're going to do a file, and this one is going to have an int main. Am I correct? I am incorrect. So we'll do a file, new, and I could have done a new enum from here. I just took the wrong choice. Okay, this one's going to be called enum. Where are we at? Enum set. No, enum test. Enum test. Okay, and we'll need a public setting for it main. Okay, so it looks like this. Get rid of that. Okay, and for this to work, we have to import the tools to work with it. So the java.util.enum set. Okay, so those are going to allow us to manipulate these. Okay, so then inside of our public class, and it's out of our main, we can use this in this way. We can just say system.out.println all books. Okay, then we can do for book dot values. Okay, and values is going to be one of the things we get from the enum type. Okay, so that's saying basically we're going to iterate through those. Okay, then we can do a book dot get title comma. Nope, that's not what we want, sorry. System.out.print F. And it's going to get percent dash 10s, then a percent dash 4s, percent dash, oh sorry, dash 45 s, percent s, percent n. Arguments are going to be the book, which is one of the enumeration we're going to pull out of the list from all of them. Okay, so the book itself, the book got get title, and the book dot get copyright year. All that. Okay, it doesn't like something. I'm missing a ending quote. That's happy enough. Okay, so that's just going to go through. Then book becomes each element of the enumeration is going to come off one at a time. Okay, go from there. Okay, so that's an example of the enumerations. They're pretty complicated. I mean, they're pretty complex in that they can do a lot. Okay, so you set them up independently of the program that you're on, kind of their own separate class, which is different from other languages. I think in Python enumeration, you just set it up right in the program. Okay, so this is more like a struct. Okay, if you're used to C++. Okay. Section 810 talks about garbage collection, just that to say that other languages like C++, you have to worry about making sure you recover memory that's used by different things. And Java takes care of that for you. That's all that section says. You don't really have to do much about that. Okay. 811 talks more about static, which we've talked about a lot before. So I don't think we need to do anything different there. And then in 812, it just talks about the idea that you can do a static import and not have to prepend it. So if you statically import the math library, you can just say py and not math.py. I'm not a big fan of that because I think that it just kind of seems weird when you do that. I like to see the math.py. Okay. 813 talks about something we've mentioned before, the idea of final instance variables. Okay, so the keyword final, we saw some over here. The keyword final, like we've mentioned before, it just makes something a constant. Okay, so you have to set it at the time that you create the final variable. I think I did one with rows and columns in a previous video. Okay, or you have to set it in the constructor every time, the two options there. Okay, so 814 talks about the package access, and there's an example there on 815, and it really introduces the protected. So protected is another keyword besides public and private that just means that other instances of the same type have access to our data. Okay, so you should read through that. There's not too much there. Okay, and then I think the last section that we're going to do is 815 on the big decimal format. Okay, so the java.math library has this. Good Lord, it's raining and my throat's irritated. What rain does for me. So let's create an example here on this big interest or big decimal. And again, it's because once you go to decimal, like a float or a double, then you can have some imprecision that because you're carrying it so many places, you can get things that aren't exactly correct. So if you're doing something that needs to be more accurate, like money things, you can do something like this. Okay, it's going to be called interest. This is an example on page 359. We'll add a public static void main to this one. Okay. So in this case, we have some imports to do. We're going to, but that happens before anything. We're going to import java.math.bigdecimal. Notice there's a big integer as well. Okay. Got to import java.text.number format, which it's also going to use in this program. Okay. And then in our public static void main, we can use a big decimal, just like anything else. So I give a big decimal principal is equal to big decimal dot value of the value of we want is $1,000, 1000.0. Okay. So we can't set it directly because it's basically its own class that we've created. Okay, but we're going to use the value of to set principal. Okay. Same thing, we do a big decimal rate is equal to big decimal dot value of 0.05. Okay, so that's going to set those two variables. Okay, then we can say a system.out.println, sorry, printf. We're going to have a %s, %20, s, %n for new line character. And then for this, we're going to get the string year. And we're going to get the string amount on deposit. Opening quote for this one. So that's %s, %20, s, %n. So the %s will be the first string. There's two there now for some reason. I don't want two. I just want one. There we go. I have to delete the second one. So there's a 20 space for that string, the new line character after we print out amount on deposit. Okay. So then we can go through, still wants one more of those, oddly enough. Then we can go through and calculate the amount on deposit for each of 10 years. Okay, so we're going to say for int year is equal to 1. Year is less than or equal to 10. Year plus plus. An open, not a close. Okay. So then I'm going to say big decimal amount is equal to principal dot multiply, got a rate dot add big decimal dot 1. Okay, it's a value 1. Okay. Dot POW, which is going to be the power function on the year. Okay, this is where we're compounding the interest for this one. And then there should just be 2 parentheses, not 3. Okay. Does it like that? Big decimal amount, PRINCIPAL. I don't know why it doesn't like that. Oh, okay. Where am I missing a parentheses at? Big decimal amount is equal to multiply. Not sure what it doesn't like there. Yeah, because it needs one there. I'm not sure if it's got a problem or I've got a problem. It's really weird. So it should be big decimal amount is equal to principal dot multiply, open parentheses, rate dot add, another open parentheses, big decimal dot one. There's one after the one. That's the issue. Dot POW year. Okay. Is it happier now? It's not happier now. I don't know why it doesn't like principal. I'm not sure what I've done. Oh. Now we're happy. I tell you, typos will get you. I forgot to notice that it was not highlighting that, which is a cool feature if you remember it. Okay. And then we're just going to print it out. So we can do a system dot out dot print f. In this case, we're going to do a percent 4D percent 20 S percent N. Over here, we're going to do the year variable, do the number format dot get currency instance, which is listed there. Okay. Dot format find the M key dot format amount. Okay, so again, this is one of the things that makes Java pretty wordy. So into this the D that we've got there, okay, we're going to start the amount we're trying to deal with. And we're going to have the number format. So sorry, this is on the string. The year is going to go into the D. Okay, so this percent 20S here is going to be the number format which we imported here for the currency, get currency instance dot format amount. So the amount's going to be formatted as currency. Okay. So we run this, we should get the following. Okay, so that was a long drawn out error-ridden program, but you get the idea. Okay, that you're going to be able to go through and we know these numbers are going to be accurate. They're not approximations because of the big decimal. Okay, and we know that we're going to format it properly because we're using the number format. Okay. So 816, we're not doing the graphical stuff. Again, I think there's enough without adding that. The graphic stuff's interesting. If this is all coming to you real quick and easy, and you don't need or you have plenty of time, then it's certainly not a bad thing to do those sections. But we're just not going to cover them for the class. Okay. So let's look at the homework problems that we have for this week. The first one is problem 8.4. It wants a rectangle class. Create a class rectangle with attributes length and width, each of which defaults to 1. Provide methods to calculate the rectangle's perimeter and area. It has a set and get methods for both length and width. Set method should verify that the length and width are each floating point numbers larger than 0.0 and less than 20.0. And then write a test program. Okay, so that should be relatively straightforward. You're creating a class that has its rectangle class as a length and width, has the accessors and mutators. The constructor and the set need to make sure that those values are both doubles between 0 and 20. Greater than 0, less than 20. Less than, strictly less than 20. Okay. 8.10 is going to have us write an enum type, which again, I didn't do it correctly, but you can change it. You can do in your Eclipse. I'll show you that real quick. Eclipse is still up there. Yeah. So remember, if we do a file, new, and you can't see that because of the way I shared it. Let me try this again. Let me share the desktop. That's easier. Go over here. Then I can do a file, new, enum right there. Okay, that's the way to do that. Okay, so we're going to create one called traffic light that has the constants of red, green, and yellow. Take one parameter, duration of the light. So that'll be how long you can make that number up, how long those lights stand for in seconds if you want, or minutes, whatever makes you happy. Or if it's in Johnson City, sometimes it seems like they're in hours. So then you can write a program to test that enum. So it displays the enum constants and their durations. Okay. Then we have 816 on rational numbers. So that's a bigger program. With that one, we're going to create a class, again, a class called rational that's going to store fractions. It's going to have a numerator and denominator. Each of those are integers. Okay. So you have to have a constructor that enables an object of this class to be initialized when it's declared. So the constructor should store the fraction in reduced form. Okay, so if you have, for example, the fraction 2,4 is equivalent to 1,2, and we be stored with 1 in the numerator and 2 in the denominator. Okay, so provide a no argument constructor with default values in case there are no initializers are provided. That idea of reducing it may be a little trickier than you think. So I would defer that. Okay, I would do everything else first. It's still going to work without it, but it won't work quite the same. Okay, but you're going to add the ability. So you have to have a method that adds two numbers, a method that subtracts them, a method that multiplies them, divides them, gives us a string representation, two different ways. Okay, so for those, just think about how you add fractions together. Should get you there. Okay. Then the last one is going to be 819, the account class with big decimal balance. So you're going to rewrite the account class that you did in section 3.4 to store the balance as a big decimal object and to perform all calculations using big decimals. That should be relatively straightforward. Okay. Again, the longest one's going to be the 816, the third of those four problems. Okay. So again, this week we're going to meet on Tuesday at 7 and Thursday at 7. And if those times are really horrible for everybody, let me know. And again, I'll record those. If you have questions and you know you're not going to be there, feel free to send those along and I will try to answer them during class time. Okay. Okay, that's all I've got for this week. I should have the answer to the midterm stuff out there relatively quickly, hopefully within 3 or 4 days. And also, I should have the grades probably it will be probably next week for the grades. A lot of people in this class, but we'll see how that goes. Okay, that's it for this week. Let me know if you have any questions.